Hello everyone, welcome back. So in this video we are going to learn about sinusoidal response. Okay, sinusoidal response. So as the name specifies, if the input is a sinusoidal signal, then its corresponding response is sinusoidal response, right? So if you are first time to my channel, please consider subscribing. So when a sinusoidal signal is applied to any system which is an LTI system, okay, so if a sinusoidal response or sinusoidal signal is applied like this to an LTI system, then its output is also sinusoidal. And the output is also sinusoidal, but there is change with respect to amplitude and frequency. Okay, so amplitude and frequency of the output changes with respect to input. Okay, so with respect to input, amplitude changes, and also not frequency remains same, phase changes. Okay, so frequency remains same, so phase only changes. Suppose if you have a sine omega t given, sine omega naught t given for you as the input, then the output is, so if this is your input r of t, then the output c of t is a into m sine of omega naught t plus, if you have plus theta also, plus theta plus or minus phi. Okay, so if r of t is sine of omega naught t plus theta, then c of t is a into m sine of omega naught t plus theta plus or minus phi. So there is only change with respect to this m and this phi. Okay, so omega naught here and omega naught here, it remains same, that is frequency remains same, only changes with respect to amplitude and phase. Okay, so what is this m? M is equal to modulus of h of j omega at omega is equal to omega naught. Okay, and what is phi? So phi is angle of h of j omega at omega is equal to omega naught. Alright, so these are the values of m and phi we have to find. So based on the system, if you are given in Laplace domain, so h of s is obtained for you just by substituting j omega, because it is also a stable system. Then we can apply s is equal to j omega, so h of j omega is obtained if h of s is given. Then in h of j omega, just substitute omega is equal to omega naught and find its corresponding modulus value, then you will get m. So just a is already given for you, so this is a here, r of t is equal to a sine omega naught t plus theta. If r of t is equal to, so a is the input amplitude here, a, and m is the amplitude which is scaled. Okay, so this m is called as scaling factor in amplitude. Okay, so this is called as scaling factor or improvisation. Okay, so scaling factor in amplitude, and this is scaling factor in phase. So scaling factor in phase at the output side. Okay, so this is how we can find the sinusoidal response. So if your input is sinusoidal, then the output is also sinusoidal. Okay, so let's solve some examples, then you will understand very clearly about the concept. Okay, so now we'll solve this problem. So in this problem, he has given that a closed loop transfer function of unity feedback system is given by this c of s by r of s is this, and the input is r of t is sinusoidal signal, then its corresponding output is dash. Okay, so same sinusoidal analysis concept we can use. Okay, so r of t is equal to, what is the standard form? A sine omega naught t plus theta. So here there is no theta, so a is going to be 1 and omega naught value is 1, because omega naught 1, when omega naught is equal to 1, then it becomes sine t. So it is sine t now given. So comparing these two, so we have a is equal to 1, omega naught is equal to 1, and theta is equal to 0 degrees, comparing with the standard form. Then comparing with the standard form, what is C of t, that is output, is given by a into m sine of omega naught t plus theta plus or minus here phi. Okay, so a we have 1. Okay, so we'll substitute this later. Okay, so this theta is also equal to 0. So first of all we have to find this m and phi. So in order to find m and phi, we have to use transfer function. So C of s by r of s is 1 by s plus 1. So this can be taken as h of s. This is transfer function, h of s. So by substituting s is equal to j omega, substituting s is equal to j omega, we'll get h of j omega is equal to 1 by 1 plus j omega. Here also in the place of s we are substituting with j omega. Okay, so now omega naught is equal to 1. What I have told you, m is equal to modulus of h of j omega at omega is equal to omega naught. So at omega is equal to omega naught, so 1 by 1 plus j, so at omega is equal to omega naught, so substitute with omega naught. In the place of omega you have to substitute with omega naught. So modulus of 1 by 1 plus j, what is omega naught? 1. So j into 1 is j only. So modulus of this value is 1 by root of 1 plus 1. So we know that modulus of a plus ib is equal to root of a square plus b square. Similarly, so you'll get 1 by root 2 here. So m value is 1 by root 2. And 5, what I have told you, 5 is equal to angle of h of j omega at omega is equal to omega naught. So h of j omega angle, so since it is in denominator, we will write minus tan inverse of imaginary part. Imaginary part is omega divided by real part is 1. So omega by 1 is omega. At omega is equal to omega naught. Omega naught value is 1. So is equal to minus tan inverse of 1. So it is minus pi by 4. So this is 5. Okay, so this is how we can find the values of m and phi from the given transfer function. So once you find m and phi, then you can directly substitute in C of t. You'll get the steady state output. So a is 1, so 1 into m is 1 by root 2. So 1 into 1 by root 2 is 1 by root 2 only. Sine of omega naught t. So omega naught is 1. So 1 into t is t. And phi is also 0. So this is also 0. So we can leave that. And phi here, phi is minus pi by 4. So it is minus pi by 4. So if you have minus sign here, you have to take the same sign. If you have plus sign here, you have to take the sign same. That is what plus or minus represents. Okay. So this is the final steady state output of this input signal. Okay. So directly you can find from the formula. Okay, so general procedure, if you don't use this method, or if you can't remember this method, what is the procedure you have to follow is, we have to take this r of s, that is Laplace transform of r of t. Now it becomes 1 by s square plus 1, and then again C of s is equal to r of s. R of s is multiplied here, so r of s is multiplied with 1 by s plus 1. So this is r of s, so it is multiplied by 1 by s plus 1, so it becomes now 1 by s plus 1 into s square plus 1. Now again we have to find the partial fractions, and again at last you will get the same answer only. Okay, so even if you find like this also, you'll get the same answer only. You can try it on your own. Okay, so now we'll solve a previous grid problem on the same concept. So he has given a transfer function here, s by s plus p. So y of s by x of s, which is equal to transfer function h of s is equal to s by s plus p. So it has an output y of t is equal to this, and for the input x of t is equal to p into cos of 2t minus pi by 2. Then what is the value of p he is asking. So he is asking to find the value of p. So p we have to find. Right, same concept here. If you compare x of t is equal to p into cos of 2t minus pi by 2. Okay, so a is going to be p and omega naught is equal to 2 and phi is equal to minus pi by 2. Similarly, y of t he has given both input and output. Okay, so 1 into cos of 2t minus pi by 3 has given. That means this value is a into m. Yes or no? A into m, and this is omega naught. And what is this pi by 3? So it is phi plus or minus phi is equal to minus pi by 3. Okay, so a into m is equal to 1. So we'll use this and solve this question. Okay, so what is m here? So m is given by modulus of h of j omega at omega is equal to omega naught. So here omega naught is equal to 2. Yes or no? Cos of omega naught t. So if not only sinusoidal, if it is cosinusoidal also, the same concept can be applied. If the input is cosinusoidal, then the output is also cosinusoidal. Only changes with respect to amplitude and phase. Okay, so it is s, h of j omega. First of all, you have to find. So h of j omega can be found by substituting s is equal to j omega. So j omega by p plus j omega modulus at omega is equal to 2, because omega naught value is 2. So what you have is j2 by p plus j2 modulus. So when you take modulus of j2, you'll get 2 here by root of p square plus 4. Root of a plus modulus of a plus ib is root of a square plus b square. So you'll get 2 plus p. So this is value of m. And from this equation, a into m is equal to 1. What is a value? So a value is p into m is this 2 by root of p square plus 4 is equal to 1. So 2p is equal to, so send this term this side, so it is multiplied by 1, so it becomes root of p square plus 4. Taking square on both sides, squaring on both sides, so we'll get 4p square is equal to p square plus 4. So it is 3p square is equal to 4. So p square is equal to 4 by 3, this implies p is equal to 2 by root 3. Okay, so this is the answer, and this is how we can solve these type of questions. So any input is given in sinusoidal form or in cosinusoidal form, you can solve by using this simple concept. If input is sinusoidal, sine or cosine, output is also sine or cosine, only changes with respect to amplitude and phase. Okay.